Up the 7.7 notes. Okay. So B, what do you think B would be? It's a little more complicated. So how would we do the square root of positive 18? How would we do that? Yeah, so what are the perfect square factors of 18? Just 9. So we would rewrite 18 as 2 times 9. Okay? So the square root of 18 is the same thing as the square root of 2 times 9. That's the same thing as the square root of 2 times the square root of 9. Or just 3 root 2, yeah. Now for the negative there, we just put an I. So the answer would just be 3I root 2. Okay, 3I root 2. The negative just means we throw in an I. Can I move on to C? So C, this one's a little different. What's different about C? Where's the negative? It's outside. Yep, it's outside. So this is the same thing as just negative 1 times the square root of 4. What's the square root of 4? So it's just negative 2. That's the answer to this one. Negative 2. Okay. All right, can I move on to D? So 5 times the square root of negative 20. How would I simplify the square root of just 20? How would I simplify that? Yeah. So what are the factors of 20 that are perfect squares? What's a factor of 20 that's a perfect square? 4. Yeah. So I can rewrite this as the square root of 4 times 5. Which is the same thing as the square root of 4 times the square root of 5, which is the same thing as 2 root 5, okay? What would that negative inside the square root do, though? Make it 2I root 5, yep. So this becomes 5, we keep the 5 there, times 2I root 5, okay? That 5 times 2 there, we can just crunch those together, so it's 10I root 5. Is this making at least a little bit of sense? So we just need to make sure we know, like again, one theme that's come up a lot in this course is you need to make sure you know how to write down the factors of various numbers, okay? All right. The square root of negative 3 times the square root of negative 7. I'm going to go to the left here. How would we do the square root of 3? Does it have any perfect square factors? No, it doesn't. So it just stays like that. We can't simplify any farther. What about the square root of 7? No. No perfect square factors. We just keep it as the square root of 7. Okay, you can only pull out numbers from underneath the square root symbol if there are perfect square factors. Okay? So then what would a square root of negative 3 be? It'd just be I root 3. Just throw an I on there. Okay? Square root of negative 7 would be I root 7. Okay? So whenever there's a negative underneath, you just throw an I in. Yeah, basically. So this becomes the square root of negative 3 times the square root of negative 7. That becomes I root 3 times I root 7. Not in this course. Okay? I root 3 times I root 7. Okay? Do you guys see how we can multiply the i's together? So there's I times root 3 times I times root 7. So it's actually more like I times root 3 times root 7. Okay? I squared, sorry, I squared. Okay? And what's I squared equal to? Negative 1. So it's negative 1 times root 3 times root 7. Okay? I think I'd probably accept that answer, but you can simplify it further. I'd prefer that. What's root? You can rewrite root 3 times root 7 as just root 21. So this is negative root 21. Okay. So you can combine them into one square root. You can combine these two numbers into one square root by just multiplying these two together. Are we feeling okay about that? Yeah.
Could you also put, can it just be I squared root 21?
Make it -1. Yeah, that's a very important idea. It's a very important idea that I squared equals -1. So I want you guys to write that down. This one right here, F's not too bad. Can I move on to F? Okay. Square root of 25 times the square root of -1. What's the square root of 25? 5. What's the square root of -1? I. So it's just 5i. Okay. G, I would do this one step at a time. So I'm going to highlight square root of 4 in red. I'm going to highlight square root of -8 in blue. I'm just going to leave that other negative there. What's the square root of 4? 2. Okay, so it's times negative. What's the square root of -8? Let's think about what that is. Okay. How would I do the square root of +8? What is that? 2 root 2, yep. And then what does the negative there do? We just throw an I in there, 2i root 2. Yep. So this is 2 times minus 2i root 2. Okay.
Would the I ever go in front of like the 2 on the outside, or will it always go between?
What do you mean like in front of? Like write it like I2 root 2?
Yeah.
That's not mathematically wrong. That's just not how mathematicians usually write it down.
Okay.
Yeah. It's kind of like you always write it like 2x. You never write like x2. Yeah. Okay. So then 2 times -2i root 2, that's just -4. I just crunch those two integers. That 2 and that -2, I just multiply together. Gives me -4i root 2. Are you feeling okay about that? All right, so that's just a little introduction to simplifying square roots that have negatives underneath them. Okay. All right. Can I move on to the next topic? Okay, I'm going to move on to the next topic. Okay. Okay, add or subtract. So we're going to add or subtract these numbers. So a complex number, let me introduce a new term up here. A complex number, that's a number that has a term with I. A lot of the times you can just treat I like a variable. Just treat it like a variable. It's a number that has a term with I in it, and a term without I. Without I in it. Okay? So down here, 3 minus 5i, this is a complex number. Okay? You guys see how there's two terms in this number? There's a 3 and a 5i, a minus 5i. Okay? So there's a term 3 that does not have an I, and then there's a term minus 5i that does have an I. That's why it's called a complex number. Yes. Yeah. Okay? Right. In a number like 3 minus 5i, we call the term that does not have the I, we call it the real part. The real part of the number. We call the term that does have an I, we call that the imaginary part. Okay, it's called the imaginary part of that number. Okay? All right. So it's just little bit of vocabulary. My iPad's almost dead. That stinks. All right. So for adding and subtracting complex numbers, all you do is you combine like terms. It's not that different from what we did in chapter 4. Okay. So here, right, we combine the 3 here, the real 3 that does not have an I, and then that 2 that does not have an I. Those combine to 5. And then we combine the parts that do have I. So that negative 5i and that 4i, the plus 4i, those would simplify to minus I. Minus 1i. Okay, so we combine them just like, we treat I like a variable. It's just a special variable that has the property I squared equals negative 1. Pretty much. Okay. And then B. Would you guys be able to do B on your own? Okay, try B on your own real quick. Give you like 30 seconds. What'd you guys get? 6 plus 2i, yep. So remember, I like to change this, right? I like to distribute the negative. So 8 minus I minus 2 and then plus 3i, okay? Combining like terms, we get 6. That 8 and that minus 2 combine to 6. And the 3i and the minus I combine to plus 2i. Okay? Okay? You okay about that one? Multiply. For something like this, I'm going to make a note. For multiplying complex numbers or numbers that involve I, you multiply as usual. Except every time you see an I squared, you change it to a negative 1. Okay, like give you guys a couple seconds to write that down, right? So for multiplying, you multiply these numbers together as usual, except every time you see an I squared, you just have to change it to negative 1.
And then do you change it to negative 1 before you multiply?
You can change it to negative 1 like at the end. So 6i times 8i, right? That would be multiplying as usual, right? That would be what? 48 I squared, right? And then I squared just has to get changed to a negative. So this is negative 48. Okay. Is this making sense? Okay. All right. B, negative 3i times 5i, right? What would that simplify to? Negative 15i squared, right? And then that I squared here, right? We got to change that to a negative 1. So it's negative 15 or positive 15. All right. And then, like I was saying before, for part C, we would just distribute that 2i like we would do with like a regular variable. So 2i times 4 is 8i. 2i times minus 9i is minus 18i squared. Okay. So that 8i stays the same, but that minus 18i squared, if we change this I squared to a negative 1, this becomes plus 18. Right? The real part is 18. The imaginary part is 8i. Okay? Can I move on to D? For this one, multiply as usual. So just FOIL, guys. Just FOIL, okay? So first, 2 times 1 is 2. Outer, 2 times 4i is 8i. Inner, I times 1 is I. Last, I times 4i is plus 4i squared. Okay? Okay? And then this I squared here, I just have to change to a negative 1. So 2 plus 8i plus I minus 4. Okay? And then I just combine like terms. Okay? So it's minus 2 plus 9i. Okay? Are we feeling okay about that? So you really do stuff as normal. You just, every time you see an I squared, you change it to a negative 1. Okay? Can I move on to E? Move on to E. All right, E, right? 3 minus 2i squared. What is that not? What do I not want to see ever? Don't do it. What do you think someone's going to write down for this?
9 minus 1.
Someone's going to think it's 9 squared minus 2i squared. That's wrong, right? Remember, guys, this is equal to 3 minus 2i times 3 minus 2i, okay? We can't just distribute the square. You have to FOIL it out, okay? So let's FOIL that first. Outer, inner, last. Okay. Okay, 9. Those 6i, the minus 6i's combine to minus 12i. Minus 4i squared becomes plus 4. So 13 minus 12i. Okay. Yeah, what's up?
Would it be
Did I do something wrong?
positive 4i? It's not-
It would be, thank you. It'd be plus 4i squared. I'm sorry, I made a little mistake. Sorry, guys. So I made a little mistake when I multiplied the last. Minus 2i times minus 2i, that's going to be plus 4i squared. So it's going to be 9 minus 12i minus 4, or 5 minus 12i. Sorry about that. Thank you, Joey. Can I move on to the next topic? Divide. Divide. Okay? This one's a little different. I don't think we've talked about dividing too much. So for this one, for A, I want to make 2 notes here. So A, we have to divide A. So, let me make a little note. When there's just an I in the bottom, you multiply the top and bottom of the fraction by I. Okay? This is not a complex number in the bottom because it only has an imaginary part. Okay? When there's only an imaginary part, you just multiply the top and bottom by I, okay? So here's what I mean. I'm just going to multiply, so let me put parentheses around the top. I'm just going to multiply by I over I, okay? Multiplying straight across the top, I get I times 4 plus 2i. Multiplying straight across the bottom, I get 3i squared. Okay. Okay. So the bottom simplifies to just minus 3. The top, I distribute the I. I get 4i plus 2i squared. Plus 2i squared is just 4i minus 2 all over negative 3. That's my answer. Did I go through that too fast? Okay. By I over I. So do you guys remember, did they teach you in Algebra 1 or Geometry that we don't like to have square roots in our denominators? They teach you that? Yeah, so we don't like to have square roots in our denominators. I, what's I the square root of? Square root of negative 1. So basically when you have a fraction that has an I in the bottom, you got to get rid of that I. So you multiply the top and bottom by I. We can do that because we're multiplying by I over I, which is just 1. And a number times 1 is equal to itself. Okay. Are you guys okay if I can move on to B? Now what's different about B, the denominator in B? Yeah, it's complex. There's not just a 3i, there's also a 2 there, right? There's also a 2. Okay? So when there's like a whole complex number, let me make a little note, I'll make it in pink. When there's a whole, or I don't want to say a whole, an entire complex number in bottom, what you do, you multiply the top and bottom by what's called the complex conjugate of the bottom. Complex conjugate, okay? Okay, you guys, does anyone know, no one probably knows what I mean by complex conjugate. So if I have a complex number a plus bi, just some, its complex conjugate we find, but you just flip the symbol in the middle. Okay, these are complex conjugates. Okay, so what's the complex conjugate that would multiply the top and bottom by here? 2 minus 3i, yeah? So I multiply the top and bottom by 2 minus 3i. Okay, multiply on top, right? Just distribute the 6. You get 12 minus 18i, and then FOIL in the bottom, okay? FOIL in the bottom. Luckily, when you multiply, so let me use my pointer. When you multiply these two numbers together, it simplifies really nicely, okay? So if we do FOIL here, we do first 4, outer, that's minus 6i. The inner is plus 6i. When we multiply the last, we get minus 9i squared. You guys see what happens down there in the middle and the bottom? Yeah, the outer and inner one products cancel. Okay? And then that minus 9i squared changes to plus 9. Okay? So we get 12 minus 18i over 13. Okay? And I'm sorry, guys, I misread the directions here. They want you to write your answers in a plus bi form. What that means is they just want you to take the answer and split it up, just split up the numerator. So it's 12 over 13 minus 18i over 13. So that would be the answer. And I should have done that for the first one too. Okay. Did I go through that too fast? Are we okay? All right, so then C. Would you guys be able to do C on your own real quick? Why don't you guys try C on your own real quick? I'm going to ask Mrs. Hollis a question real quick. She's not teaching. Try C on your own. do we get?
I know the top is 6 plus 17.
Okay.
And then bottom would be 16. Is it plus 9?
I don't know. I was about to do it right now. Yeah. All right, you guys want to go through this real quick? So what do I have to do? I have to multiply the top and bottom by what? 4 plus 3i, yeah, the conjugate, the complex conjugate of the bottom. Okay? All right, so that's going to be 3 plus 2i times 4 plus 3i times 4 minus 3i times 4 plus 3i, okay? The top is going to FOIL to first, outer, inner, last. Okay. Bottom is going to FOIL to first, outer, inner, last. Okay. So let's simplify the bottom real quick. Are you guys okay? That plus 6i squared, I'm going to change that to a minus 6. Okay, that just changes to a minus 6. Okay. These two in the bottom cancel out. And then minus 9i squared, that changes to a plus 9. Okay, did you guys follow that? Okay. And so we have, combining like terms, we get 6 plus 17i all over 25. Let's split up our numerator, okay? So that's 6 over 25 plus 17 over 25i, okay? Make sure your fractions are simplified for me. Okay, is that what you guys got? Okay. Yeah, so I just asked Mrs. Hollis if there was anything else I need to do today because we have a lot of time left. I just finished. So let me talk about the series.